Alright, this lesson we're looking at trees and minimum connector problems. So a connector problem is when we are connecting all the vertices in a graph with the minimum number of distance. So in order for us to do that, we should find the minimum spanning tree on a graph. Before we get into it, just to cover some of the basics, whenever we talk about a tree in terms of a graph, is a connected part of the graph where it has no loops, multiple edges or cycles. So for example, if I just take this bit here, that can be a tree for this graph. This can also be a tree. This can be a tree. This can be a tree. And this can be a tree as well. Or, yep, so again, this entire thing can be a tree, or even if you just take some parts of it, that can also be a tree. A spanning tree is when we have all the vertices connected in a graph. So for example, if we were to draw a spanning tree for this one, we can just find sort of any combination as long as we connect all the vertices together. So this can be one, this can be one, or it can be like this one. So there are multiple ways to do so. Now, our goal is to find the minimum spanning tree. So obviously we can just do it however we like, as long as we're following, not covering multiple edges or cycles. But there are a couple of things we can do to make sure we're finding the minimum spanning tree. And the way we're going to do it is to use Prim's algorithm. And here are the steps of how to do it, and I'll jump right into this example to show you how to apply these steps. So the way to do it is you pick any point to start. So our goal here is to find the minimum spanning tree. So you can pick a point to start. Let's start over here. So let's use this color here. And then your goal is, from the vertex that you have right now, which is just A at this point, find the lowest connecting edge. So right now we have 2, 5, and 6 connected to A. Find the lowest one. As you can see, it's the 2 here. And then, just like draw over that edge. And from here, we have both vertex A and B. We look at all of different options that's connecting these two. So we got the not connecting these two. We look at all the edges that are connected to A and B. So these two are connected to A. This one's connected to B. So look at all these 4 options, choose the lowest one, and it's this 5 here. And that's what we've chosen. So now we have connected A, B, and D. And again, look at all of the options that's connected to the vertices that we have currently. So it's this one, and this one. And choose the lowest one, and it's this 3 here. So delete everything except for this 3. And we continue this process until we connect all the vertices. So here we've got now 8, 6, 6, 7, 5, 6. So the lowest one is this 5. So draw this over 5. And then now we're almost there. And for this last one, again, look at all of the options. And then now you can tell it's the 2. That's the lowest. So, and as you can see, we've created a spanning tree, and this has to be the minimum spanning tree applying Prim's algorithm.